Hi everyone, back with a new video. It's exercise 10C. This is called selections. Before we actually start, try and think about what selections mean. Imagine having a library of books and you're selecting one of the few things. So there's different ways you can select a few books from a library with a lot of books. That's what selections means. Our learning intentions are to define and apply the concept of selections or combinations. These two words are synonyms of each other, because if you think about selecting a few books from a library, that means you've got a combination of books. We're also going to be computing the number of combinations using NCR. I'll show you what this notation means, and it turns out to be a formula. Our success criteria is can identify problems involving combinations and compute the number of combinations using the formula. We start off by looking at this example. Given 4 people whose names are A, B, C, and D, how many selections of 2 people can be made from this group of 4 people? Without introducing any formulas yet, we can just go ahead and list out all the possible combinations. So let's do that. The combinations are as a set of pairs of people, as a set of 2 people at the same time. We can have person A grouped with person B. Or we can have person A grouped with person C. Or person A with person D. There are 3 possible combinations where you pick A first. Now, considering person B can be grouped with person A, but we've actually paired them off already. In other words, if you select person A first, then person B, it's the same as just selecting person B first and then person A. They're still the same pair of people. Now, person B then can be selected with person C, and then person B with D. Okay, now let's consider picking person C. We've already got combinations of C with A and C with B. The only combination that we haven't considered is person C with person D. So let's write that down. And we've got all of our 6 people. I'm not going to consider person D now because person D has actually been grouped together with all the other 3. Just from listing these combinations, we can see that there are 6 ways of selecting 2 people from 4 people in total. It's a very tedious way to do it, and it gets very difficult, nigh impossible, when you have much more than 4 people in your group. That's why we're going to introduce this formula. Of important note, once again, person A with person B and person B with person A is only one combination. The order doesn't matter. So if you've got one pair of people, then you don't count them twice if you switch their places around. Here's what the notation for combinations look like. We write it as NCR. That N is placed a little bit above the C and R is placed a little bit below. So I'll rewrite it NCR. It should look like this. The N and the C and the R represent different things. You may have guessed that C represents combinations. So this thing helps us calculate the number of combinations. N is the total number of objects that we're choosing from. In our example from before, that would be the 4 people A, B, C, and D. R is the number of objects that are being chosen from the total group. So in the example before, the value of R would be 2 because we're only selecting pairs of people. The formula looks like this. NCR equals n factorial divided by r factorial multiplied by the difference between n and r factorial. I realise that this formula looks quite complicated, and I've just kind of thrown this to you without any explanation. That's the unfortunate bit about not exploring exercise 10b in total, because exploring exercise 10b, you do get an idea of where this formula comes from. But for this exercise, we are just expecting you to know how to apply this formula to calculate combinations. One more thing, NCR is a way to write the number of combinations. Another way to write the number of combinations would be like this. In brackets, n at the top, r at the bottom, and we use these curved brackets. It kind of looks like a fraction, but we don't put a fraction in the fraction line in between. And it kind of looks like a matrix, but we've got curved brackets. This separates a combination from a matrix. Okay, let's see how we can apply the formula. I've rewritten it here. Let's see how we can apply it to the example that we did before. How many selections of 2 people can be made from a group of 4 people? Okay, so we have our formula. I'd always rewrite it in every question. And then we need to identify what the n value is and what the r value is. N represents the total number of people to choose from, in this case 4 people. So let's reference that value, n is 4. R would be the number of people that you choose from the total group. In this case, we're only choosing 2 people. So now we can rewrite our formula with the values substituted in. 4, choose 2. You'd say this in words as 4, choose 2. It makes sense anyway, like 4 people, choose 2 of them. That's equal to 4 factorial, I'm summing it in now, divided by 2 factorial, multiplied by the difference between the total number and the people you're choosing from. In other words, find the difference of n and r. That's 4 take away 2, which is 2. I'm going to pause here and point out that the bottom 2 numbers, the values that you've subbed in, they'll always add up to the number at the top. So that's a way to check that you're on the right track. Now, why that works is considering the r and the n minus r. I've told you that when you add them together, you get the number at the top. Algebraically, we can show that. R plus n minus r. Okay? That's like r plus n minus r. I can drop the brackets, and then the r and the r, they eliminate each other, so the result is just n. Quick way to check that you're on the right track, just by adding the numbers together and seeing if it makes the top. Now let's go ahead and evaluate these factorials. At the top we've got 4 times 3 times 2 times 1. And at the bottom we've got 2 times 1 times 2 times 1. The numerator seems like the number's going to be very big. I'm not going to multiply everything together because I can spot that there are a few numbers that can cancel out. So I cancel out everything before I do any evaluations. In fact, the other numbers here, the 2, that can cancel out with the 4. So the answer just becomes the result of 2 times 3. They're just the numbers that are remaining. So let's write it out. 2 times 3, that's 6. That means there are 6 possible combinations of pairs of people from a total group of 4 people. Notice that our answer was the exact same answer as the way we did before by listing out all the particular combinations. Okay, a few things to note. There's a few identities that can really help you if you can remember these. Firstly, I'll rewrite it bigger so you can see. N choose 0. From a group of n objects, you choose nothing. Well, how many ways can you choose nothing? From the 4 people, you're going to choose no one. There's only one way of choosing no one, and that's just to choose no one. the answer is 1. Anytime you see a 0 for the number of people that you choose, there's only one way to do it, no matter how large the size of the group is. Now, you can prove it mathematically. If you're inclined to do so, okay, this is optional, NC0, that's equal to choose 0, that's 0 factorial, and the difference between n and 0 factorial. You can simplify this, and you can also see that n choose 0 is 1. I'll leave it to you. But one fact that you need to use is the fact that 0 factorial is 1. We identified that in the previous exercise. That's important for this part of the numerator. Some other identities. If you have a group of things and you only choose one of that group, example, if you've got 4 people and you're only choosing one person from that 4, how many ways can you choose one person? Well, there are 4 possible ways, because you could have just chosen one person from that group of 4 people. So, n choose 1 would be n. Choosing one person from a group of 4, there are 4 ways. Once again, you can prove it. I'll even write it out. N choose 1 is equal to n factorial over 1 factorial times n take away 1 factorial. This one's a little bit harder to prove. If you'd like to do it, go ahead, but I wouldn't spend too much time on this. Knowing logically that if you choose 1 from a group of n objects, there are only n ways to do it. And next one, n choose n equals 1. Going to the 4 people example, if you've got 4 people and you choose 4 people, that means you're choosing everyone. And there's only one way to choose everyone, which means the number of combinations is 1. 7 choose 4 is equal to 7 choose 3. So if I tell you what the value of 7 choose 4 is, you can say that it's also equal to 7 choose 3. For this example, I'm actually going to tell you what the identity looks like, because I reckon this one is also important to know, just like all the others. Okay, so if I'm going to write out 7 choose 4 as a formula, 7 choose 4, that's equal to 7 factorial divided by 4 factorial times 3 factorial. I got the 3 from finding the difference between the total number and the number of things you choose. The key fact is to notice that 4 factorial and 3 factorial, they're being multiplied together, and with multiplication, you can do it in any order. So I can as easily write it as 7 factorial over 3 factorial times 4 factorial. I've just switched the 3 and the 4. So that means, considering the 3 as the variable at the front, I can rewrite it as 7 choose 3. The implication of this is that the number of combinations where you choose 4 objects out of a group of 7 is equal to the number of combinations where you choose 3 objects out of a number of 7. The key there is that 4 and 3 both add up to 7. So they turn out to be the same number because the 4 and the 3 can be switched around. Here's our first big example with numbers that are quite large. This will be example 4, question 12 of 10C. I recommend that you get your booklet out and copy this example down as we do it together. In how many ways can a committee of 5 be selected from 8 women and 4 men? A committee is just a group of people. In the first question, we're asking for the number of ways without restriction. That means we're not worried about picking a certain number of women or a certain number of men. These women and men could have been just identical. So let's have a think. We're choosing 5 people, R is 5, out of a total number of people. There's 8 women and 4 men, so N is 10. That's like the, it's 12. That's like the addition rule at work. So to set up our formula, we have 12 people and we choose 5. Now I'm also going to write the other notation, 12 choose 5. You don't have to write both ways, just pick one and go with it. Now what that's going to equal to is 12 factorial over 5 factorial multiplied by the difference between the 12 and the 5, which is 7 factorial. Pause for a moment to check that this is correct. 5 plus 7 does get you 12. Now it's just a matter of trying to evaluate these really large factorials. And the trick there is to try and cancel out before you evaluate the factorials. Rewriting 12 factorial as 12 times 11 times 10 times 9 times 8 times 7 factorial. So that 7 factorial implies that it does go down forever. But I stop here because you can notice that this 7 factorial cancels out with the 7 factorial in the denominator. So I'll stop here and I'll save myself some energy. And we divide that by 5 factorial. I'm going to write out the full thing because it's the other factorial that cancels out. Okay? So cancel out these factorials. That's a key step. That's going to save you time. I'm going to start cancelling the other numbers before I evaluate. So what numbers can I cancel? I see 2 and 5, which cancels with 10, and 4 and 3, which cancels with 12. Obviously, there's many ways to cancel. Try and pick the ways that gets rid of everything at the same time. You're left with 11 times 9 times 8. Okay? 11 times 9 times 8, and now it's just a matter of evaluating this smaller number of multiplications. 11 nines are 99. 99 times 8 is 792. If you wanted to know how I got that quickly, 99 times 8 is the same as 100 take away 1 times 8. So I figured out 100 times 8, which is 800, then I minus one of them, which is 792. That 792 tells us that there are 792 ways that you can choose 5 people from a total of 12 people in your group. Let's do an example now where you get a condition on the number of people that you choose. How many ways can a committee of 5 be selected if there must be exactly 3 women on the committee? Let's think about what this means. There must be 3 women, so we're going to choose 3 of them. How many women are there? Well, there are 8 women, which means we start off with 8 and then we choose 3. 8 choose 3. But then there are 2 empty spots remaining. The 2 empty spots then must be men. If they're not women, they've got to be men. And we're choosing 2 men from the group of 4. Now we apply the multiplication rule here. 4 men choose 2. Because each combination of women has many combinations of men. To make that a bit clearer, I know already from a previous example that 4 choose 2 was 6. So each combination of women has 6 combinations of men. Because we're choosing the women and the men successively, then we've got to use the multiplication rule. Okay, by the way, another way to write it, this is 8 choose 3 times 4 choose 2. So, 8 choose 3 is 8 factorial over 3 factorial times 5 factorial. And we multiply it with 4 factorial over 2 factorial, 2 factorial. I know that this part is 6, but I'll still write out the whole thing so you can see how we do the entire question in one go. Okay, let's start simplifying. I'm going to skip a step here because I know that from 8 factorial, some parts are going to be cancelled out with a 5 factorial. So at the top, we've got 8 times 7 times 6 from the 8 factorial, but I'm not going to write the times 5 because I'm going to do that step of cancelling in one go. So the 5s all disappear because they're cancelled out, but what remains are the 3 factorial at the bottom. 3 times 2 times 1. So that's our first fraction. Our second fraction, I'm also going to do the cancelling in one go. We get 4 times 3 in the numerator, and at the bottom we've got 2 times 1. The 2 times 1 in the numerator has cancelled out with one of these 2 factorials. Okay, let's do some cancelling. This is my favourite part. So 3 times 2 cancels out with 6. 2 cancels out with 4. So our question becomes 8 times 7 times 2 times 3. 8 times 7 is 56, 2 times 3 is 6, and 56 by 6, 6 is 36, 5 6s are 30, plus 3 is 336, and the answer is 336 committees that can be formed if you choose 5 people, but 3 of them must be women. At this point, I might show you an example where we apply the CAS. I'm going to drag this CAS green cross because even though we've got a rule to help us deal with very large numbers of combinations, sometimes the combinations are still incredibly large. So we're going to be using our CAS to calculate. I'm going to change the number just a bit and choose 5, and choose 6. So n choose 6. That means you've got a group of 10 objects and you're selecting 6 things from it. So in your calculator, you need to go to your calculator program. We're going to add a calculator in now. And we're going to figure this thing out. Press menu first. Then we're going to go to probability. Then, out of these combinations, you would have used factorial before, we're going to choose option 3, which is combinations. And then you get this option, a very familiar looking option, where you can enter things in the brackets. Now I'll list down the steps once again. We go to menu, then 5 for probability, then 3 for combinations. And what you get is this thing in your calculator. So the syntax, or the way you enter it, is like this. What you have is NCR on your screen, and in the brackets you should enter the value of n first. In this case it's 10. From a group of 10, choose 6. So after the comma, you'd enter a 6. And then your calculator will tell you how many combinations there are. Let's do that now. We've got 10, then comma, and a 6, enter. There are 210 combinations. So this is how you can use your calculator very quickly and avoid having to use a formula. One more thing that I'll point out. Remember before when I said that if you have something like this, well, this is also going to be the same as this. And this is just the case where I've switched the 6 with the 4. In other words, the combinations where you choose 6 things from a group of 10 is equal to the number of combinations where you choose 4 things from a group of 10. Let's just show that it is actually correct from a CAS. Calculating 10 choose 4, menu, then probability and combinations. We press 10, then comma, all. And this is just shown that the number of combinations is actually the same. I do recommend that you get your CAS out now and do what I've just done following our steps to see that your calculator shows the same things. Don't want to get to a test and your calculator doesn't do the correct thing. Okay, let's work through an example now where the numbers are actually humongous and we really do need a CAS to work through this. The selections of a sporting team needs to choose 10 athletes from 15 track and 12 field athletes who have qualified to compete. How many groups are possible? In this case, there are no restrictions, and we're just choosing 10 out of the 27 possible athletes. From 27, we choose 10. You can use your formula. I'm going to tell you right now that the answer is humongous, but from your CAS, you can get, the answer is 8,436,285 groups. Imagine getting this number by listing out all the combinations one by one. You'd never see the end of it. And this is the power of the formula for combinations. It gets you the answer in basically one step. Question B, how many groups would contain track athletes only? In this case, we're choosing 10 athletes from the 15 tracks and from the 12 field athletes, we're choosing no one. So let's write that down. I'll use a different notation to get you more familiarized. Choosing 10 from the track athletes. From the 15 track athletes, we choose 10. At the same time, from the 12 field athletes, we choose no one. 12 choose nothing. You can use your CAS once again to do this as well. The numbers for this isn't going to be that big, so I'll do it by hand. One more thing, your calculator won't be able to enter combinations like these brackets. You do have to use the NCR function to help you find the number of combinations. So once you do that for both, you just multiply them together. Okay, 15 choose 10. Let's do this by hand. 15 factorial over 10 factorial, 5 factorial. 10 plus 5 is 15, we're all good. Okay, next, we do 12 factorial over 0 factorial times 12 factorial. At this point, I'll mention that if you remember one of the identities from before, if you have a certain number of objects and you choose no one, there's only one way to do it. So this actually cancels out to 1, which means I could have also just stated that this is 1. So let's do that now. We need to evaluate this 15 factorial fraction. We've got 15 factorial, which is the result of 15 times 14 times 13 times 12 times 11. I don't write 10 because it'll cancel out. Divided by 5 times 4 times 3 times 2 times 1. Doing our cancelling down step, we notice that 3 times 5 cancels with 15. And 4 and 2, okay, well 2 cancels with 14 to become 7, and 4 and 12 cancels to become 3. So our answer becomes the result of the remaining numbers. 7 times 13 times 3 times 11. Let's work this out. 7 times 13 is like 7 times 10 plus 7 times 3. 7 times 3 is 21. So it's 70 plus 21, which is 91. 3 times 11 is obviously 33. And what's left is to multiply this. Okay, 91 times 33. We have 3 times 1, which is 3. 3 times 9 is 27, 273. Then we multiply 30 with 91, which is just like 3 times 91, but a place value up. We add that 0. And 3 times 91 is 273. Add these all together, and we get 3. 7 plus 3 is 0, with a 1 carried across. 2 plus 1 plus 7 is 0, and 3. 3, 0, 0, 3. In other words, without a CAS, for this particular question, 3003 numbers of ways or 3003 groups that contain track athletes only. Question C, how many groups would contain field athletes only? Basically the same question, this time around, from the 15 track athletes, you're not going to choose anyone. And from the 12 field athletes, you're going to choose 10 from them. So let's write it down. From the 15 tracks, you choose no one, and from the 12 fields, you choose 10. So the answer is 6 times 11, which is 66. 66 are groups that contain field athletes only. If you think about it, it makes a bit of sense because there has to be less possible combinations if you're choosing from 12 people compared to if you're choosing from a larger group of people. D, how many groups contain half track and half field athletes? So half would mean you're going to be choosing 5 athletes from track and 5 athletes from field. I know that there are 15 track athletes, we're going to choose 5 from them. And from the 12, I also choose 5. Now it's going to be quite a big number. I've done this in my CAS. Just enter in each of these individually, then multiply the result. And your answer becomes 2, 3, 7, 8, 3, 7, 6. 2,378,376 groups, which contain half track and half field athletes. I know I skipped steps. It's more important that you understand how to set up your combinations because your calculator will answer these questions for you. So this is about selections or combinations of any size, and you're going to add them all together. When asked to count all the combinations of any size from a group of n objects, you add the combinations of choosing none of them, one of them, 2 of them, and so on, until you've chosen all of them. And this actually equals 2 to the power of n. Remember before, when we started this chapter with the Indian physician who out of the 6 taste senses, taken 1 at a time, 2 at a time, and so on, there were 63 possible combinations? Out of 6 senses, in total, there are 2 to the n, which is 2 to the power of 6. Now this equals 64 because it's added on to that the fact that you're eating something that has no taste, which is why the Indian physician actually used the formula 2 to the 6 minus 1, because you're going to remove that combination where you taste nothing. And that's 63. We're finally up to the maths where it was discovered 2,600 years ago. Okay, so this is the formula. But what you really need to understand is that when you take a combination of any size from a group of n objects, it's just equal to 2 to the n. It's important to understand where that 2 to the n comes from. So here's how to explain it. Let's consider selecting 3 different books, and they can be called A, B, and C. There can be one particular way where you choose no books. In other words, 3 choose 0. Okay, and there's one way of choosing nothing. If you choose 1 book from the group of 3, then there are 3 ways. If you choose 2 books from the group of 3, then there are actually 3 ways as well. 2 ways to think about it. 3 choose 1 is the same as 3 choose 2, because the 1 and the 2 add up to 3. The other way is just listing the number of ways out. So you've got picking A and B, that's one way. A and C is another way, and B and C is your third way. So 2 books to be chosen, 3 ways. And lastly, how many ways can you choose 3 books? There's only 1 way. So the total number of combinations is found by the addition rule. The total number of choices then would be the number of ways that you could have picked any number of books from 0 to 3. And if you add these up, it gets you 8. We got these from what we had previously. So this is one way of figuring out the total number of ways. This accounts for the left-hand side of our formula. The right-hand side comes from the fact that we can consider whether or not we pick A, whether or not we pick B, and whether or not we pick C. So if we focus on successively selecting one book at a time, there's two ways that you can choose book A. You either choose it or not. Okay, there's your two ways. There's also two ways where you can choose B. You choose it or don't choose it. And book C, you also choose it or don't choose it. And because you're deciding successively, one at a time, then that's based on your multiplication rule. Because there are 3 books and there are 2 ways of whether you choose it or not, then the total number would be 2 times 2 times 2, which is 2 to the power of 3 ways. 2 to the power of 3 is 8. It turns out that different ways of thinking about the same question still gets you the same answer, which means the formula that we've given here, 3 choose 0 plus 3 choose 1 plus 3 choose 2 plus 3 choose 3, which is 8, is the same thing as just finding 2 to the power of 3. This is where the right-hand side comes from. So let's see if we can apply an example to this. Example 6. Nick goes to his local hardware store and buys a hot dog. There are 4 sauces, which are tomato sauce, barbecue, mayonnaise, and custard, to choose from, and Nick can choose to pass or select any number of them. So that means there are 4 different sauces in total. Let's write it down. And Nick can choose to get one of those sauces, or a combination of 2, or a combination of 3, or 4, or Nick can also choose none of them. So the answer to this is 2 to the power of n, and if n is 4, it's 2 to the power of 4, and it equals to 16. 16 different combinations of sauces. Now, in the next question, if Nick chooses at least one topping, how many choices does Nick have? There are 16 ways in total, but there's only one way of not choosing any topping. And if you exclude the fact that you're not going to choose any topping, that means Nick is going to choose at least one of them. So the answer is going to be 2 to the n minus 1, which is 2 to the 4 minus 1. 16, take away 1 is 15. 15 combinations where you do actually put some sauce on your hot dog. Okay, once again, at the end, just to mention about CAS. CAS is going to be so essential to calculating combinations. I'm going to list the instructions here if you'd like to copy it down into your book, but please also remember to try this in your CAS as well to make sure it's working. We're going to wrap up now with going through the learning intentions. So to define and apply the concept of selections or combinations, I hope you can understand what these words mean now. And to compute the number of combinations using NCR. Can identify problems involving combinations and compute the number of combinations using NCR. Remember the formula, it's going to help you. N factorial over n factorial times n minus r factorial. Oops, I've already made a mistake. It's r, where n stands for the total number of objects in your big group, and r is how many you're choosing from. And the notation can be written in another way as well. I recommend now to do the style questions below to check your understanding and whether you can move on.